Now that we've looked at a strong acid, strong base titration, let's look at a weak acid, strong base titration. And here we have 25.00 milliliters of a 0.1 molar acetic acid solution, which is a weak acid, versus 0.1 molar sodium hydroxide. The first point we're going to look at is what is the pH before adding any base. And remember that when we have a weak base, it's going to be in equilibrium with H plus C2H3O2 minus. And the Ka for this particular expression is going to be 1.8 times 10 to the minus 5. So if we set up an ice table with our initial concentrations, we have 0.1 molar in the acid and 0 H plus and 0 C2H3O2 minus. Our change in concentration is going to be minus X for this acetic acid, plus X for the H plus, and plus X for the C2H3O2 minus. Our equilibrium concentrations then are going to be 0.1 minus X, X, and X. So our Ka is going to equal the concentration of H plus, which is X, times the concentration of C2H3O2 minus, which is also X, divided by the concentration of the acetic acid, which is 0.1 minus X. This equals 1.8 times 10 to the minus 5. If we use our approximation, we can say that X squared divided by 0.1 is roughly equal to 1.8 times 10 to the minus 5. This will give us a value of X that'll equal 1.32 times 10 to the minus 3. X is our concentration of H plus at equilibrium. So if we take the negative log of this, we get the pH, which is 2.83. So this is going to be our first point on our acid-base titration curve. When we have 0 base added, our pH is going to be 2.83. So now in the next video, let's look at what the pH is going to be after adding 10 milliliters of the 0.1 molar sodium hydroxide.